Class example 3.58. Jeremiah invests $10,000 into a GIC, which is a guaranteed investment certificate, that earns 5.8% interest compounded quarterly, which would mean 4 times per year. Assuming he makes no additional deposits or withdrawals, determine the value of the investment in 15 years, and then round to the nearest whole dollar. So we'll start with our compound interest formula, where A will be equal to 10,000, so that's our principal amount. And then it would be 1 plus, and then at this point, this would be our interest rate for the year. But we're compounding 4 times per year. So we need to divide that by 4 to figure out the interest rate per compounding period. Our N value is the total number of compounds. So 4 times per year for 15 years, which would be 4 times 15, so 60. So we get approximately 23,720. Determine how long it would take for the investment to double, rounded to the nearest year. So again, we'll start with our compound formula. And now let's find N when A is equal to double P, or 2P. So we can replace A with 2P. And then we can divide both sides by P. And we get the following equation. Now, I just want to go back one step. We could have just replaced our principal amount with really anything we wanted. We just had to make sure that our A value was double whatever our P value was. So an easy one to do, maybe you make your principal amount $1, and we see how long it takes to turn that into $2. And then, so if we did that, actually, we would have just started with this equation, right? Because there's $1 turning into $2. But that could have been 100 turning into 200, whatever you like. Okay, so now at this point, we're going to convert this into log form. So our base here was this. It's 1.0145. So that's our base. So that'll be the base of our log of 2 is equal to the exponent. So our N value is approximately 48. But remember what that is. That means there's 48 compounding periods. So we could divide that by 4, which would be 12 years. C. Construct an alternative function that models the value of the investment after 2 years using the doubling period found in B. Show that this new function is equivalent by determining the value in 15 years. So if we start with our general growth and decay formula on your formula sheet, then we could say, well, this should be 10,000. One more 0 in there. And then times 2, because we're doubling, to the power of t over, and then where'd this 12 come from? Well, that was what we found in the last part. It was 12 years. It was approximately 12 years to double, right? And that, our p value is the amount of time for our multiplier to happen, right? For that 2 to actually double. So if we plug that into our calculator, we get 23,784, which is off by actually a bit. And we're kind of expecting that because we did round this. When we said this was approximately 48 and approximately 12 years, we rounded that number. So we were going to be off a little bit, but it's close. It's a close approximation.